Hello, welcome to my paper circuit STEM lesson. So I started with the engineering process. So I quickly thought of an issue that comes up with my students where a lot of them walk to school and the ones that don't walk wait for the bus out in rural areas. And it's often dark and foggy most mornings during the school year, especially in the winter, and how they don't always like to wear proper visibility stuff because it doesn't look cool. So here was the challenge I thought of. How can we create a prototype backpack or sweatshirt tag to increase visibility in dark and foggy conditions? So then I added this criteria and these constraints, and then I started to imagine using the paper circuit kit and just figuring out how the circuits work in general, which I would allow students to explore that and kind of help create that knowledge of how it works before they start creating their own tag. And then also just brainstorming different safety products, like what's out there and the different constraints and like what's required and what works and what doesn't work. And then also thinking about how to attach the tag and how to keep the tag lasting, like in the different conditions. And with sixth graders who are often rough with things, like how can we keep the tags sturdy and work well despite the conditions. So then I started to plan. So here's the materials I gathered, and then just started to figure out some potential designs. And then with the help of my husband and my son, we made 3 different designs. We used the same paper. 2 were white, 1 was orange, and then we decorated them as we saw fit. And then we tried 1 light, 2 lights, and 3 lights. But as I get into the improve, the 3 light wasn't as effective as you can kind of see in this picture. So we started with the circuitry that was kind of suggested using the kit. And then we kind of modified it as we went, as you can see here in this picture. And then for time's sake, instead of trying to get the 3 to work, I just did to 2, which worked a lot better. But I'll talk about it more in the next slide. So we decided that having a LED strip light would be so much better than the individual light bulbs, and even having retroreflective tape or something of that nature would be very helpful. And we also found that attaching the battery pack to the back or inside to make it not as easily seen but still get to the switch also messed with the circuitry, and it took some effort to get it to work. So here was our results when we tested it out. So again, that would be something in the classroom. How can we test it out? Here at home, I was able to have a dark basement that I can make completely dark or partially dark. And at school, maybe using a box instead. So I tested it at 5, 10, 15, and 25 because 25 was the furthest. And we also tested to see if the light color made a difference. And you can tell not as much, but when there was more light bulbs, that did make a difference. And for this one, when I had the green and the yellow, the green didn't show up as well as the yellow, but then when testing the green on its own, I found it was a circuitry issue, not necessarily the color itself. Then we also tested it where it wasn't as dark, but still dark enough to see if the colors and designs made a difference. In this regard, it didn't make that much of a difference, but again, having more reflective tape or something would have been helpful. Here's my lesson plan. You can see that it's attached to my post to look at it closer. And then for the Jolly Design lesson plan, this was a problem that applied to them. It was interactive. It was when we were discussing, we brought in different math and science content. It was collaborative. We were able to, students are going to test their solutions, have a chance to discuss. So this was like a yes the whole way down. All right. Thank you for watching. Bye.